Hi everybody, good morning. I'm continuing doing rooms in web application pen testing path. There was one left here, multi-factor authentication. I'm doing this one today. This one is that's not complex room. It's but there is a niceties you can check other rooms to practice. So multi-factor authentication, exploiting multi-factor authentication. MFA play an important role in modern day application. Instead of just relying on password, MFA throws an extra layer of defense. Basically, MFA is a combination of different check. It might be something you know, like a password, something you have, like your smartphone, send you an SMS or code, or something you are like a fingerprint. So that's what the name multi-factor authentication objective in this room is. Understand the operational principle of MFA and its significance in strengthening an application security posture. Explore the different type of authentication factor used in MFA. Gain insight into practice scenario MFA is implemented to protect sensitive data and system. Some prerequisites, yeah, some Linux things like that, not necessary. Now you can start having your machine IP, so we can have our labs. So that's the lab, and then the MFA is. Sorry, what I'm doing. Vim it is. I'm opening with the VI. Okay, that's fine. Same. The old friends. So because an MFA, what was the So you have three labs for this. We're doing three labs. There's OTP leakage, SQL coding, and beating the auto-logout. So let's start first of all. Let's do that in case someone need assist in this room. Now, how MFA works into the digital age, keeping our sensitive data and system secure is more important than even multi-factor authentication and extra protection to use a account by requiring you to provide two or more verification factor. Most now, if you look for example that authentication app that you install in your phone whenever you log in now, you can even activate it in WordPress where you log in, then you go to your app in your phone, it generate that code, you type it. That's usually most now Twitter, X, LinkedIn, they all using it now. So that's MFA. So something you have, something you know, or something you are. Fingerprint, for example, even your phone now you can use your fingerprint, your retina, your eye. Something you know. This could be password, pin, in any piece of info that you have to remember. Something you have is but your bio here, or no, something you have could be the phone with authentication. Otherwise, mostly use authentication apps, security token, even smart card. Lately, we have seen more use of client certificate, which is like a digital ID card. Something you are using for biometrics such fingerprint, facial recognition, or eyes scan. Yeah, this authentication is getting popularity because it's tough to fake and not found in many gadgets. Something somewhere you are, this involve your origin IP of your location. Some application like online banking usually they verify restricted activity. They detect they are making request from unknown IP address. Something you do, this kind of authentication is usually used in application that restrict boot interaction, okay, like registration pages and things like that. Kind of 2FA. 2FA is a advice mechanism to ensure each authentication factor provides a robust security layer. Time-based one-time password. Okay, this one is known. This is our temporary password that change every 30 seconds or so. Applies. That's the one I use myself. This one, Google Authentication, Microsoft Authenticator, and also use them, making them tough for hacker to intercept or use. Push notification, SMS. Usually you get that one. Hardware token is more secure, I think. Conditional access. Location based, time based, behavior analysis, device specific. global adoption and regularity push. The adoption of MFA is rapidly happen, so you can read about this. Numerous bridges and things like that. When logging into the application, you receive an SMS and your phone containing one-time password. What authentication you have? So yeah, this is something you have. So because you have that SMS, so you can give that something you have. Um, Implementation and application. Multi-factor authentication is now an important factor keeping your online offline activity safe, especially banking, handle increased sensitive information and transaction every single day. Banks can protect user personal and financial information. Type ask you to enter password, something you know, before moving to the second layer of security, which is a code sent via SMS. Okay. Uh, MFA in healthcare. In healthcare, due to regulatory like HIPAA in the US, MFA makes sure that patient record and personal health information only accessible by authorized person. MFA incorporate IT with an increasing number of cyber attack and data. IT department in the corporate world are under intense pressure to protect sensitive business. Now become more dangerous with AI and faking phone calls and all of that. Is MFA an important factor in keeping our online and offline activities safe from threat actor? Yeah, that's just right. So basically, this first task is more introduction, if to give you an idea if you not know about it. Common vulnerability in MFA. So we have weak OTP generation algorithm. Of course, mean you can guess it like 1, 2, 3 or whatever. Security of one-time password is only as strong as the algorithm it uses. Application leaking, this is our first lab. If an application handle data poorly, a brute force, that's why you always have a rate limiting for OTP, so you don't have a brute forcing. Lack of rate limiting, that's what we talk about now. For example, in this report, the tester was able to report a valid bug since the application doesn't, and that's what they tell you. If you are doing bug bounty, don't assume that developer did all their checking. So he might think this is so obvious to you're supposed to have it, but you can see someone just got free bonus. Usage of even evil jinx. This even I remember 2 months or month ago the latest version was out. This yeah, version 3. So usually they use it for phishing. Basically, you get a fake, for example, Google page for email, fake one, and the center here they have Evangelist 3, not 2. The 3 is the latest, and then will let you enter your login. So the hacker steal it, but the real data go to Google, so you can get the session and then use it to log in to a legitimate site. What can be implemented to help? Yeah, that rate limiting. Now let's practice, because when we practice we can understand better. In this lab, the first lab is OTP leakage. OTP leakage is in the XML HTTP request response typically happen due to poor implementation of 2FA mechanism or insecure coding. So this is basically insecure coding, straightforward. So it's not like you hack or something. It's straight developer side mistake. Server side validation obtains sensitive information. In some poorly designed application, the server validates OTP, and rather than just confirming success failure yes no, it returns the OTP itself. It's like by joking. But usually this happens sometimes when a developer start testing the application to make sure that everything working. It's like when you do programming, you add all this print statement to see, then suddenly you forgot when you make it live to production. Lack of proper security practice, developer might overlook the security implication of exposing sensitive information like OTP in the API response. No, let's lab one, lab first. The login are the email thm at mail.thm and password test123. Where is that lab? So let's go to the first lab. So you get this one. Of course, always when you do testing, always let your network so you can see what exactly uh, happening. So for example, now I'm in that, so you can see what's going on. So we said TryHackMe mail.tryhackme. Let me close this at mail.tryhackme, and then you go to test123. Now you can see that's a font MFA. It's sent to token here. We didn't steal even. It was a post request to get. Of course, you can do via page source. Let's see what's a page source is. The font we don't have nothing special there. Uh, Document add event list. That's the one for submitting. Handle paste, handle focus. What's going on here? Yeah, lab first token. So it called the token endpoint. So we know that from this because we can see it's calling the token first forward slash token, and then if we look at the response of it, it's already in the response, and that tell you that's the weakness, the leaking. So it leaking 5070. Uh, so this is basically the first lab. Once you have page, and then as you can see the extra request submitted to the token endpoint, and above the application return a response with a size of 16 bytes. Click request, and we can see the response, and this is the weakness. So it's 5070, so we can go 50. So this is not supposed to give us that. So, and then we got the dashboard, and of course you got your first flag. So the issue here is the leakage. This is a programming problem here, not supposed to send the data back. So that's why the title of this task talk about uh, OTP leakage. So the application endpoint, the what was that endpoint again? Uh, yeah, the endpoint leaked was leaking the OTP itself, and then we got it. So that straightforward. This is a programming issue. The next one is task 6, practical insecure coding. This one again related to insecure coding. In some application, flawed logic or insecure coding practice can lead to a situation where critical part of the application, for example, dashboard, can be accessed without fully completed authentication process. Now, basically, this one, what is it? Let's go to that lab. So, if I go, for example, insecure coding, you get there. So, you go back to network. So we can go same things, tryhackme at mail.tryhackme and test123. The issue is, like, for example, now if I go again, we have a token here, but it's a response, it just says success, so we are not there. The issue here is it mean the developer, because the entry point is that, so he make double things like that. But you can just say, if I go, for example, second, and let's say a forward slash dashboard, and now you can see that you went through without any uh, asking for this. You can be strange. So it mean, remember those two process. Let's not where's the logout? This is a second, so we can remember this is second. Let me refresh it again. I'm out. Now, in a normal operation, if I put dashboard as second dashboard, I'm not. It asks me for the password. So the endpoint dashboard is protected by the password. So it look fine. Now here, if I go to second, it redirect me to a login. So it makes sense. So if I log in and say try me, sorry, at mail.yasham and test 123. Now it protects. So the endpoint it go after login you get to MFA, but the developer logic is wrong here. In the endpoint dashboard, it's only protected by the password. So there is no 2MFA on this one. So one, two, three. You go straight to login. So this is a logical flow in the application, and that's what he's talking about. For example, when you go here, it mean we log in. It mean let's see what happened. In the first endpoint, the main one, you have two functions that authenticate you. You have the login. This is the if verify code post. If successful, the user will be redirected to the dashboard. So if session authentication to session that is used to check if the user completed 2FA, and you go no. Now consider the implementation is secure. Some instance of dangling insurance of the session authenticated. For example, in this one, if authenticated mean after your login, uh, authenticated is true. This flag should only be issued after the MFA, and basically it goes straight to else goes straight to that. Since the application dashboard only check for the value, so it only check if you are authenticated. It doesn't check for like this one for the MFA. So basically that's why we've been able to get this. This endpoint is not protected by the MFA, but it's only protected by login username or password. So this one is a programmatic logic, and it can happen even for login sessions. Like this one has two session, and this one has only one session. So and that's how this one happened. So this one is straightforward. So you need to have always if the user login, then if pass the two-factor authentication, then show them the page. If he's not login, ask for username password. After they log in, ask for the multi-factor authentication, then show the page. So it's about logic. One page dashboard wasn't protected. Now in this last lab, the beating the auto-logout feature. In some application, failing the TFA chance can cause the application to revert to user back to the first part of the authentication process, initial login. Common reason for this, we'll talk about rate limiting and lockout policy. Usually that's why you have firewall. If you type a password a couple of times wrong, you block your IP, and that's why it'll be more dangerous. So even if this script is more like real life, this script will not work, because if you keep sending OTP wrong like every time and keep logging in the firewall, you just block your IP. But this is more about learning scenario. In our scenario, let's get the scenario first. Let's close this, close this, close this. The third one, let's try the lab 31. let's keep it a habit, the network. So if I do th at mail.trammers and test 1 2 3. Of course, here there is no leakage, so you can see there is no leakage. No, this one doesn't use a token. Yeah, but there is no leakage here, so we are out. You can go also for page source in case there's some funny stuff happening. There's no funny stuff happening. This one is straightforward. And then you can, if you try, for example, 1 2 3 4, and you say verify, you're out. So every time I need to log in again, so which is it will be make it harder. So every time you want to do something, you need to come back here and put a password again, test 1 2 3. Of course, it's not blocking your IP, but you can see this challenge. Put another one, verify your account, you are logged out. So this is make it more harder, because what exactly you will do now, you can just keep doing that. So exploitation, the application host you log out the user if they fail the 2FA challenge. For demonstration purpose, the application also generates a 2-digit pin code every time the user login. So we have every time a new. Now, TryHackMe, for simpler process, they create the key small. You can see the key usually it generates from 0 to 9999, but we're not. It's too much space for a script, and then it will take time. You can see the token here. It only regenerated from 1 to 50 to 1350. So the key it's in 100 points. So the probability of like 1% chance we can get it correct. And so you make sure, but real life this one will be like 00999. So the script here is just straightforward. Now basically the script go to the third. It has username, password. Of course you need to the header, and then he has fixed the logic of the script, and then of course because the OTP is a split, these 4 inboxes. And then why we hard code, you can hard code anything depend of this, because the code is from 1 to 50, 1350. The idea here is, because the application will generate a pin from 1 to 15, 1350, there's 100 possibility. We can choose any one from this, and if we choose only one, let's random one between these two value. If we keep log in and log out and keep testing the pin one time, we will have this one will be the correct one. Uh, and of course, if it's the script look, less explanation, it's better explained there. So we have the header user agent that is standard login. You check the login response. You're looking for 200. Okay. Um, Send a 4-digit OTP, code 1, code 2, because it's split. And then OTP range, the script loops still the application respond with the same OTP. So the script just send the same OTP every time. Login attempt, OTP submission, the same format. Okay, that, and look for the 3 found, redirect. Now these two things, you can redirect to the dashboard or redirect to the third, which means login page. And here the script detect which one. Now let's take that script and test it. Uh, let's say vim mfi dot t no dot tryhame dot py. Let's do our own script, because we are not lazy, or we are lazy. Let's change this. Doesn't need to be 1337. We can test, for example, 350. Let's make it 345 in that range. I'm just to make a point. It's not necessary need to be there. Uh, and Python 3 MFI. So let's run it. You kidding me? Why is taking long? Now we got it. Because now he was able to get it, and after a while the application, because we have 1% chance to get it correctly, so you have this one. I can just go to my and I just remove this and enter straight to dashboard, and then we got a flag. So because our cookie was correct, so you can understand the script what he's doing. He's taking, because we take one OTE and we just keep using it, and once, for example, the application will find the correct, will get the same OTP as our guess. And of course in this room it's easy because the range is small. That's why I said this um, this to make a lab possible, not too much time and too much resources. And that's what you can change whatever you want. It doesn't matter. uh, I can change it to 338, the next one, like, and I can run it again. If I refresh, should be out now. No, it's still why it's my session is still on. Okay, dashboard, I'm out. Now I found this one. Let's try this one now. If I go to sorry, is storage cookie session, remove that you dashboard, and then we are in. So I hope you guys you get understand what exactly the script is doing, and the idea, of course, is brute forcing. It's a nice script to have in case you got a CTF or something. This one is room. Yeah, this room is. Yeah, it look easy because, but writing the, but now with ChatGPT and Gemini and Claude, it's not. If you get to understand how the application work, you can easily generate your Python script. So it's not like the old days you struggle writing a. Now is the key understanding how things. So when you go to an AI and ChatGPT or Claude or X Claude a group, you can do this script that do, for example, this. Like, for example, you can tell the AI, you know what, send a header to send a header to this address, use your login, and then create an OTP. That's the endpoint, and then it will generate for you the script. There's a couple of room in TryHackMe that related to this. I forgot the names, but you can check them. Yeah, this room was yeah, takeaway, understanding MFA, addressing vulnerability, common use issue like weak OTP algorithm and lack of rate limiting can undermine security. Secure OTP generation, rate limiting, and user education are crucial for maintaining effective MFI. Okay, thank you very much, guys. I'll try to do the rest. I think I've finished now this section. I will still have these ones as one. Hey, when I realized too many things I didn't do them before. Thank you guys very much and have a good day.